This is gonna blow your mind. Welcome to Space Fact Fusion. Today, we're diving into the cosmos to uncover some of the most amazing facts about space. For centuries, it seemed like the heavens held their secrets close. But with modern science, we've begun to unravel some of the most intriguing mysteries of the cosmos. From the mind-boggling expansion of the universe to the bizarre properties of black holes, prepare yourself for a journey that will challenge your understanding of the natural world. Imagine the universe just moments after the Big Bang, an incredibly hot, dense point, smaller than an atom. Then, an explosion of energy and expansion, the birth of everything we know and everything we don't. The universe has been expanding ever since, pushing galaxies further apart like raisins in a rising loaf of bread. It's not just that the galaxies are moving apart within a pre-existing space. Space itself is stretching, carrying the galaxies along with it. The expansion is accelerating, driven by a mysterious force we call dark energy. Will it expand forever, growing colder and darker? Or will it eventually collapse back in on itself in a big crunch? These are questions that keep cosmologists up at night. Have you ever looked up at the night sky and felt a sense of awe at the sheer number of stars? There are more stars in the observable universe than grains of sand on all the beaches on Earth. The next time you're at the beach, scoop up a handful of sand and try to count the grains. Our Sun, a fairly average star, is just one of hundreds of billions of stars in the Milky Way galaxy. And the Milky Way is just one of trillions of galaxies in the observable universe, each containing billions, even trillions of stars. The numbers are simply staggering, beyond our ability to truly comprehend. Black holes are among the most enigmatic objects in the universe. Regions of space-time where gravity is so strong that nothing, not even light, can escape. These cosmic giants are formed when massive stars collapse under their own gravity, creating a point of infinite density known as a singularity. But their strangeness goes beyond just their powerful gravitational pull. Black holes have the ability to warp time itself. This warping of time is a consequence of the immense gravitational forces at play. Imagine approaching a black hole. As you draw nearer, the effects of its gravity become more pronounced, distorting space and time around it. As you get closer, the gravitational pull would increase dramatically. This intense gravity would start to stretch and compress objects, a phenomenon known as spaghettification. If you were to shine a beam of light back towards Earth, the light would be stretched, its wavelength lengthened due to the intense gravity. This stretching of light is a direct result of the gravitational forces at play. This is known as gravitational redshift. The light loses energy as it escapes the gravitational pull, shifting towards the red end of the spectrum. From your perspective, as you fall towards the black hole, time would seem to slow down. To an outside observer, it would appear as though you're moving in slow motion. This is called time dilation. The closer you get to the event horizon, the more pronounced this effect becomes, until time appears to almost stand still. While we can't travel to a black hole to experience time dilation firsthand, these mind-bending concepts illustrate the profound implications of Einstein's theories and the bizarre nature of black holes. They challenge our understanding of the universe and push the boundaries of what we know about space and time. Neutron stars are the remnants of massive stars that have exploded as supernovae. These incredibly dense objects are the collapsed cores of these stars, squeezed down to the size of a city by the crushing force of gravity. Imagine taking an object with the mass of our Sun and compressing it down to the size of Manhattan. That's the density of a neutron star. A single teaspoonful would weigh billions of tons, more than Mount Everest. The protons and electrons are forced together, forming neutrons, hence the name. These neutrons are packed together so tightly that there's hardly any space left between them. Neutron stars are like giant atomic nuclei, offering a glimpse into the bizarre world of matter under extreme conditions. In the vast expanse of space, no one can hear you scream. That's because sound, as we know it, cannot travel through the vacuum of space. Sound waves are vibrations that travel through a medium, like air or water. In space, there is no such medium to carry these vibrations. On Earth, our atmosphere acts as a giant speaker, allowing us to hear the sounds of our world. But in space, there is no atmosphere to transmit sound waves. Astronauts on spacewalks communicate with each other using radios, as their voices would be lost in the silent void. The silence of space is absolute, a stark contrast to the cacophony of sounds we experience on Earth. The universe is a vast and mysterious place, filled with countless stars and planets. It's only natural to wonder if we're alone in this vast expanse, or if other forms of life might exist out there among the stars. While we haven't yet found definitive proof of alien life, recent discoveries have made the prospect more tantalizing than ever. Astronomers have discovered thousands of exoplanets, planets orbiting other stars. Some of these exoplanets are located within their star's habitable zone, the region where temperatures are just right for liquid water to exist on the surface. A key ingredient for life as we know it. Moreover, scientists have found evidence of organic molecules, the building blocks of life, in meteorites and comets. The search for extraterrestrial life is one of the most profound scientific endeavors of our time. Mars, the red planet, is home to some of the most impressive geological features in our solar system, including the largest volcano ever discovered, Olympus Mons. Imagine a volcano so massive that it dwarfs Mount Everest, Earth's tallest mountain, by a factor of 3. That's Olympus Mons, a shield volcano that stretches across an area roughly the size of Arizona. Unlike Earth, where tectonic plates move and shift, creating chains of volcanoes, Mars has a relatively static crust. This allowed Olympus Mons to erupt continuously for billions of years, building up its massive size over time. Olympus Mons is a stark reminder of the diverse and often extreme landscapes that exist within our solar system. Venus, often called Earth's sister planet due to its similar size and composition, is a world of extremes. Despite its similarities to Earth, Venus is a hostile environment with conditions that are far from welcoming. Its thick atmosphere traps heat, creating a runaway greenhouse effect that makes Venus the hottest planet in our solar system, even hotter than Mercury, which is closer to the Sun. The surface temperature on Venus can reach up to 900 degrees Fahrenheit, hot enough to melt lead. But Venus has another bizarre characteristic. A day on Venus is longer than a year on Venus. This strange phenomenon is due to its incredibly slow rotation. This means that it takes longer for Venus to rotate once on its axis than it does to complete one orbit around the Sun. Essentially, if you were standing on the surface of Venus, you would experience one long day that lasts for months. Venus rotates incredibly slowly, taking about 243 Earth days to complete one rotation. This slow rotation is one of the reasons why Venus has such extreme temperatures. In contrast, Venus zips around the Sun relatively quickly, completing one orbit in about 225 Earth days. This rapid orbit compared to its slow rotation creates a unique dynamic in the solar system. Venus's long days and short years are just two of the many intriguing characteristics of this enigmatic world. From its scorching surface to its thick, toxic atmosphere, Venus continues to captivate scientists and astronomers, offering clues about the complexities of planetary evolution and the potential for similar conditions on exoplanets. The Moon, Earth's constant companion, has played a vital role in our planet's history and evolution. Its gravitational pull governs our tides, stabilizes our planet's rotation, and has even influenced the development of life on Earth. But our celestial neighbor is slowly drifting away from us. Each year, the Moon moves about 1.5 inches, or roughly 3.8 centimeters, further away from Earth. This gradual separation is caused by the transfer of angular momentum from Earth's rotation to the Moon's orbit. While the Moon won't completely escape Earth's gravitational grasp, its slow farewell is a reminder that even the cosmos is in a constant state of flux. Imagine a planet, adrift in the vast emptiness of space, not bound to the gravitational pull of any star. These planets are known as rogue planets, and they are some of the most mysterious objects in the universe. These cosmic wanderers, known as rogue planets, are celestial nomads, ejected from their star systems and left to roam the galaxy alone. They travel through the cosmos, untethered and free, but also isolated and cold. Rogue planets are thought to form in the same way as other planets, within the protoplanetary disks of gas and dust that surround young stars. These disks are the birthplaces of planets, where gravity pulls together material to form new worlds. However, gravitational interactions with other planets or nearby stars can disrupt their orbits, flinging them out of their star systems and into the interstellar void. This violent ejection sends them on a lonely journey through space. Without a star to provide warmth and light, rogue planets are incredibly cold and dark. Their surfaces are likely covered in frozen oceans or barren rocky landscapes. The lack of sunlight means these planets are shrouded in perpetual night. Detecting rogue planets is incredibly challenging, as they emit very little light and are often obscured by interstellar dust and gas. This makes them nearly invisible to our telescopes and instruments. Rogue planets offer a tantalizing glimpse into the diversity of planetary systems and the possibility of planets existing independently of stars. They challenge our understanding of planetary formation and the dynamics of star systems. Gravity, the invisible force that binds the universe together, orchestrates a cosmic dance that shapes the very fabric of space and time. From the spiraling galaxies to the intricate ballet of moons around their planets, gravity's pull is both a sculptor and a guide. It governs the orbits of planets, the formation of stars, and even the paths of rogue planets. Without gravity, there would be no stars, no planets, and no life as we know it. It is the silent conductor of the universe, ensuring that every celestial body moves in harmony with the rest. As we study the gravitational interactions across the cosmos, we unravel the mysteries of how galaxies form, how black holes grow, and how the universe evolves over billions of years. Gravity's reach is infinite, yet its effects can be felt in the smallest particles and the largest cosmic structures. It is the force that connects us all, from the ground beneath our feet to the farthest reaches of the observable universe. So, the next time you gaze up at the night sky, remember that you are witnessing the grand cosmic dance of gravity, a force that binds us all together. Thanks for watching. If you enjoyed these amazing space facts, don't forget to like, comment, subscribe, and hit the bell icon for more fascinating content. The universe is full of wonders waiting to be discovered, from the smallest subatomic particles to the largest structures in the cosmos. By continuing to explore, to question, and to push the boundaries of our knowledge, we can unlock the secrets of the universe and deepen our understanding of our place within it. See you next time. And don't forget to share this video with your friends to spread the wonder of space exploration.